Part B, we're going to create 6 saltwater solutions and measure their conductivity. We'll use this conductivity and the calibration curve you created in Part A to determine each solution's salinity. To start, we're going to measure the mass of salt added to each solution using a scale and a weigh boat. Then we're going to add that mass of salt to a 500 milliliter beaker. Fill that beaker to the 500 milliliter mark with deionized water, and then measure that solution's conductivity with a conductivity meter. These data should be recorded into Table 2 of your lab. Okay, to start, you're going to tare the mass or the weight of the weigh boat. And weigh out some salt. Add that salt to our beaker. And fill the beaker with deionized water. We're going to stir each of our solutions to try and encourage the salt to dissolve or go into solution. You can take this time to think about what is actually happening on the molecular scale to each of the salt crystals. What's happening to the individual sodium and chloride ions as the salt dissolves into the water. Okay, didn't get all the salt dissolved, but I got the majority of it dissolved. Now to measure the conductivity of the solution. Put the probe in the solution and agitate it. So solution A has a conductivity of 5.49 millisiemens. Moving on to solution B. We're going to add 4 grams of salt to the beaker for solution B. Measure the conductivity of solution B. The conductivity of solution B is 10.18 millisiemens. Moving on to solution C. The mass of salt added to solution C is 6.2 grams. Measure the conductivity of solution C. The conductivity of solution C is 15.39 millisiemens. Moving on to solution D, tare our weigh boat. The mass of salt added for solution D is 8 grams. Right, let's measure the conductivity of solution D. So the conductivity of solution D is 18.97 millisiemens, 18.97. Move on to solution E. Mass of salt added to solution E is 10 grams. All right, measure the conductivity of solution E. The conductivity of solution E is 23.36 millisiemens. So the mass of salt added to make solution F is 12 grams. Let's measure the conductivity for solution F. The conductivity for solution F is 27.77 millisiemens. So you now should have all of the data you need to complete this lab. But before we go, I just want to talk about a couple sources of error in this experiment, in the methods for this experiment. The first source of error that you probably noticed is that I was not successful in getting all of the salt to dissolve in any of the solutions A through F. So that is a source of error. You also might notice that if you were looking at the readings of my conductivity meter, between each solution I've been putting the probe in this rinse beaker or rinse container that contained deionized water, and the conductivity of this water has increased throughout our experiment. So that is also another source of error where if I didn't get the probe completely dried off before I put it into my solution, it's possible that I actually increased the salinity of the solution. So those would be the possible errors in this experiment, and they're in every experiment. Okay, good luck.